In this video, the concept of Remedial Action Schemes, or RAS, is introduced. Study case O2A should be activated. Remedial Action Schemes are objects that are stored in the operational library. Let's look at an example. A simple RAS will consist of a trigger and an action. If the RAS is considered during contingency analysis and the conditions defined in the trigger are met for any contingency, then the action will automatically be carried out for that contingency. Here, the RAS has been set up to reduce the output of two generators if a particular line is overloaded as the result of a fault. The trigger is that the loading on NEL3 is greater than 100% post-fault. The actions are to reduce the output of both NEG1 and NEG2 by 200 megawatts. The RAS is not related to any particular contingency. The generation reduction will happen for any contingency that causes this overload. There are 7 contingencies selected in the contingency command. We run these, and we can see from the colouring on the graphic that at least one causes an overload on NEL3. We can also see this by running a report. Now we will execute the contingency analysis again, but this time consider remedial action schemes. For now, we will only consider the one RAS. On this page, we will select the option to be notified in the output window every time a RAS is triggered. The command is executed. We can see that the RAS has successfully reduced the post-fault loading on the circuit, which is now coloured orange rather than red. If we look at the output window, we can see that the RAS was triggered once by the contingency NEL4. Now, let's add more RAS into the list for consideration. The contingencies are run again. The output shows that it's possible for one contingency to trigger more than one RAS. If it's necessary for a remedial action to be specifically for one fault case, the trigger should be set up to reflect this. Here, the trigger is the opening of specific circuit breakers as the result of a fault. The actions model a generator intertrip. The generator breaker for NEG1 opens, and in this example, 2 other generators increase their output in order to replace some of the lost generation. In this operation scenario, we have one circuit already switched out. Let's further assume that the adjacent circuit has a reduced thermal rating. If this double circuit is faulted, line NWNEL4 is likely to be overloaded. Let's first look at the situation without RAS being considered. By executing the contingency as a single contingency, we can see the post-fault flows on the graphic, and we see that NWNEL4 is indeed overloaded post-fault. Now we can repeat with the RAS being considered. The generator trips and the load on the circuit is brought under control. it's possible to construct more complex trigger definitions. In this case, for example, we have two trigger conditions combined with an AND logic. The first is that there's been a fault on bus bar BB in substation NW01. The second is that there is some generation running. For the purposes of illustration, this trigger has been constructed using a logical gate where the state of each of the three generators is considered using negation flags and an OR combination. The action triggered is a drop in the local demand. Logical gates can be nested, and further flexibility is provided by allowing the user freedom to select any variable for consideration. A check button is provided on the RAS to help the user ensure that the RAS triggers and remedial actions are valid. And there's a description field which is particularly useful for documenting more complex remedial action schemes.